Hello and welcome to SudoKanard. We're here to solve this coded clone Sudoku, which is the last puzzle in this series of video. This was created there again by Slovakian author Diana Škrhová. It was featured in round 3 of Sudoku Grand Prix in 2024. And what is happening is that those regions bearing the same letter, and I put the same color for this penpa version. So those regions with the same letter and color must contain the same digits in the same positions. So this digit must be the same as this. This digit must be the same as that, and so on. So 49 points, and I think I found it to be not that hard for 49 points, but what is my memory? I'm not sure. So let's first solve the bottom of the grid. That has to be a 2. Those are 3 and 4. There's already a 3 on this row. On this row, I need 4 and 9, so that's 4 and that's 9. Here I need 5 and 7. And here I need 5 or 7. So that's the beginning. Now let's see what is very constrained. I'm thinking digit 1 is very constrained. 1 is excluded for some regions. Well, perhaps that's not the right place to look. Perhaps 3 here. 3 has to appear here. And it can't appear in this A region, so 3 is around here. It could be there. So I would just pencil mark it this way. There's a 3 in here. Perhaps this is a promising place. If you look at this cell, which is cloned, it must be different from all of those digits, so it must be from 5 and 8. And this 5 or 8 must appear somewhere in here. I'm not sure that's so interesting. Actually, I'm seeing that this cell can't be 8, and those cells can't be 8. So I'm sure that this region that is cloned here cannot contain an 8. And this cell is cloned here, it can't contain a 5. So this digit, that's not definitive, definitely not. So perhaps I should look elsewhere. Yes, this cell follows the same trend. This cell here is also different from all of those digits. So this cell must also be 5 or 8. So we have a 5-8 pair in those two positions. So now the remaining cells in this column must be from 2, 4, 7. And those two digits here are cloned to those cells. But I'm not seeing any elimination at this point. And those 3 cells must contain 1, 3, and 6. So this here is from 1 and 6, and it's the same as this. This is the same as this, and it's also from 1, 3, and 6. And the same is true for that. Right. What about this? This is different from all of those digits. And it's also different from 5 and 8, so it must be from 2, 6, and 9, I think. That's correct. This digit here is also there, so it must be different from those. So it must be from 2, 5, 6, and 9. I'm not sure I can do better than that. Oh, there's a 6 here. So this is from 2, 5, and 9. And I'm actually seeing that this 5 here must appear in one of those 2 cells, which means this or that. Oh, and that's very interesting. Let's have a look at that. So one of them here is a 5, and the 5 will be here or there, which means that this can't be a 5 anymore because this cell sees both this cell and this cell. So this has to be an 8, and this has to be a 5, which now bounces back to prevent this from being a 5. So this here is a 5. This is beautiful use of geometry. So that now this is 7, this is 5, this is 7, this is 5, sorry. And those are 3, 4, 7 to be disambiguated later. Now this 7 removes 7 from those cells, and this is 7. We're left with a 2, 4 pair, which eliminates 2 from this cell. Actually, this is not a 6, so this is actually a 9, something that I should have found from the start. Not that it was a 9, but that this was not a 6. This is 8 to complete the column. And now this column still needs 2, 3, and 6. So this can only be a 3. And those are 2 and 6, but 6 is not in this cell, so this is a 2, and this is a 6. This 2 disambiguates that. That's a 4. That's a 2. Nice. Here we need 7, 8, 9. So this, not being a 9, must be from 7, 8. This is not 8, so it must be from 7, 9. And this is not a 7, so it must be from 8 and 9. Here we need 1, 3, and 4. Seeing this digit here has to be a 1, so this is not a 1 anymore. Those must be 3 and 4. Nice. I'm seeing that 5 is nowhere here, and so 5 must be somewhere here, but this cell is the same as that, and it's not a 5. So 5 is here. This first row needs a 6 and a 9. There's a 9 here, so that's a 6, and that's a 9. So now this is a 1. 2 in this box can only be here, so this is, oh, actually there's a 9 here, so this is 7, this is 8, and this is 7, and this is 7 by just the clone property. This 6 here, actually this is not a 6, not a 1, so that's a 3, that's a 6. This 6 is cloned into this cell. This is now a 4, cloned here. Those are 3s, and the rest, it's just standard Sudoku. So we need a 1 there, a 2 here. That's a 9. This is 4, this is 7, this is 3. I said 3. That has to be 4, this is 5, this is 8. And that's it. So 49 points was most probably the right number of points for this puzzle, and it had a really nice use of geometry. Really, really nice. Thanks for watching this video. See you Sunday with round 4 of Sudoku Grand Prix by Chinese author Si Yuan Luo. Very difficult round, I must say. See you soon.